This question says determine the roots of equation z plus 2i whole cube is equals to 216i, where z belongs to complex number, giving the answer in the form of z is equals to a root 3 plus bi, where a and b belongs to integer, right? So let us solve this question. This question can be solved in multiple ways. We will see three ways to solve this question. So first of all, let us discuss its first method. So I'm going to discuss method 1. So the given equation is z plus 2i whole cube is equals to 216i. So we can write z plus 2i whole cube not. We will shift this power to other side. So this will be 216i raised to power 1 by 3. So this can be written as z plus 2i is equals to 6 and I raised to power 1 by 3. The whole question shift to this concept, how we can find the cube root of I. So let us see how we can find the cube root of I. Cube root of I. That is, we have to find I raised to power 1 by 3, or we can say we have to find cube root of I. So how we can find? It's very simple. So I raised to power 1 by 3. I can be written as what? How we can write I? I can be written in this form, cos pi by 2 plus I sin pi by 2. This is I, and raised to power 1 by 3. Since we have to find multiple roots because it's a cubic equation, so we should have three roots. So we should write it in general form. So this can be written as this cos pi by 2 plus 2n pi, this plus I sin pi by 2 plus 2n pi. This is the more general way to write this expression of I. This is still I and raised to power 1 by 3, right? So as we know, this power will go in the angle and this will become cos pi by 6 plus 2n pi by 3, this plus I sin pi by 6 plus 2n pi by 3, where n is equals to 0, 1, 2 and so on. So let us put first n is equals to 0. When we will put n is equals to 0, we will get cube root of I is equals to cos pi by 6 plus I sin pi by 6. This is the first cube root of I, and its value should be equals to, that is the root 3 by 2 plus I by 2, right? Similarly, when we will put n is equals to 1, what we will get? We will get cube root of I is equals to, put n is equals to 1 in this expression here and here. So we will get cos 5 pi by 6 plus I sin pi by 6. And we have to find the value of cos pi by 5 pi by 6 and sin pi by 6. Its value should be equals to minus root 3 by 2 plus I by 2. If you have any doubt how we find the value of this cos 5 pi by 6 and sin 5 pi by 6, please let me know in comment section so that I can include in some of other video. So let us put n is equals to 2. So cube root of I should be equals to, put n is equals to 2 here and here. So what we will get? We will get cos 3 pi by 2 plus I sin 3 pi by 2, and the values of these will be equals to cos 3 pi by 2 0 and sin 3 pi by 2 is equals to minus I. So this will be 0 minus sin 3 pi by 2 is 1, so 1 into I, that's the minus I. So we get the three cube roots of iota. So we have to put the value here and we will get the answer accordingly. So first, when n is equals to 0, let us substitute the value. So z plus 2I is equals to, what was the value? So value was this for 0. This was the value. So we have to substitute this value. So let me minimize this. So we can write this is 6 times and root 3 by 2 plus iota by 2. Let us simplify this. Z plus 2I is equals to 3 root 3 plus 3I. So what will be Z? Z will be equals to 3 root 3 plus I. This is the first answer. Now let us put for n is equals to 1. So we can write z plus 2I is equals to 6 times, and this is the value of cube root of iota. For n is equals to 1, this is minus root 3 by 2 plus iota by 2. So let us simplify this expression. So this z plus 2I is equals to minus 3 root 3 plus 3I. So from here we will get the value of z as minus 3 root 3 minus I. This is the second solution of the equation. Similarly, put for n is equals to 3. Let us put for n is equals to 3. So we will get z plus 2i is equals to 6 times of minus of I, because the third root was this. So z is equals to minus 6i minus 2i, that is the minus of 8i. So this is the third solution of this given equation. I hope you have understood the solution of this question. This was the first method. Let us see next method. So for the next method we have see, this is the method 2. This is the method 2. The equation is z plus 2i whole cube is equals to 216i. We have given that our z is in form of this a root 3 plus bi. So we can substitute the value of z here. So let us substitute here. So a root 3 plus bi, this is the value of z, plus 2i as given in question whole cube is equals to 216i. So let us rearrange the left hand side in separately real terms and imaginary terms. So this is a root 3 plus b plus 2i whole cube is equals to 216i. The simple concept here is I will expand this left hand side expression and equate this left hand side with right hand side separately, its real part with real part and imaginary part with imaginary part. So I am going to expand this a plus b whole cube with this identity. A plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. So this identity will be used here. So a cube, it's a cube, it means 3 root 3 a cube plus b plus 2 cube, and I cube basically I cube becomes minus of I. When you will do I cube, basically I'm saying I cube is equals to minus of I. So similar directly I am putting here a cube plus b cube plus 3a square b. So 3a squared, that is a 3a square, b, that is a b plus 2i plus 3ab square. So 3a root 3 and b square. When you will do the square of the second term, you will get I square, and I square is equals to minus 1, and this is b plus 2 whole square, and this should be equals to 269. Let us collect all the real terms together and imaginary terms together. Simple. So this is the real term and this is the real term. So collect it together, and I can see that there's something common. So 3 root 3a is common. So let us take it common. From here you will get a square plus, sorry, here you will get minus, because you have a minus 1 here. So this will be minus b plus 2 whole square plus, I'm going, this is the imaginary term and this is my imaginary term. Is there anything common? Yes, b plus 2i is common, and what we will get here? So when you will take b plus 2i common, I am writing first this term. So this you will get 9a square minus b plus 2 whole square. This should be equals to 216i. So now the next step is very simple and very logical, that you have to equate this left hand side and right hand side, two complex number. In left hand side and right hand side you have written two complex number, and two complex number will be equal if their real parts are equal and their imaginary part is equal. So here you can see its real part is 0. So the first equation I will get 3 root 3a square minus b plus 2 whole square. This should be equals to 0, and the second one will be b plus 2 9a square minus b plus 2 whole square should be equals to 216, right? So from here we have to solve for a and b. We have two unknowns and two equations. It can be solved very easily. So here in the first expression, as we can see that we have a factor, we have two factors, something multiplied by something equals to 0. So from here you will get either a is equals to 0, or either a square minus b plus 2 whole square should be equals to 0. So from this expression you will have the condition like a square should be equals to b plus 2 whole square, right? So our solution will be get solved in two segments, for a equals to 0 and for a square equals to this. When a equals to 0, use the second equation, that is the b plus 2, and it's 9a square minus b plus 2 whole square. This should be equals to 216. So when we will put a equals to 0 here, what we will get? So 0, so it's b plus 2 minus, it's minus b plus 2 whole cube is equals to 216. So from here it's minus of b plus 2 is equals to, or we can say 6, right? The cube root of 216 will be 6. So from here b plus 2 is equals to minus of 6. So from here b is equals to minus of 8. So what's the solution in this case? A is equals to 0 and b is equals to minus 8. This is the first pair of a and b as a solution. Next part, when a square is equals to this, use the second equation here again. So the second equation was b plus 2, it's 9a square minus b plus 2 whole square is equals to 216. As we know that a square is equals to this, so write it, b plus 2, it's 9a square, so 9. In place of a square, we have to write b plus 2 whole square minus b plus 2 whole square should be equals to 216. So this will be equals to b plus 2. This will be 9 b plus 2 whole square minus this, so this will be 8 b plus 2 whole square, so this will 8 b plus 2 whole square will become here cube is equals to 216. So b plus 2 whole cube will be equals to 216 divided by 8. So b plus 2 should be equals to cube root of this, that is a 6 divided by 2, that is equals to 3. So from here you will get b is equals to 3 minus 2, that is equals to 1. So b is equals to 1. When b is equals to 1, let us again use this relation for this case. As we know, a square is equals to b plus 2 whole square, and b is equals to 1, so 2 plus 1 3, 3 whole square 9, so a square is equals to 9, so a will be equals to plus minus 3. So what's the solution here? Here a plus 3, then b is equals to 1, here a is equals to minus 3 and b is equals to 1. So the complete solution will be, what was our solution? It was root 3a plus b. Our answer should be in this form. So from here we have multiple options. First use this, so it will be root 3a plus b, a is equals to 0, so it will be 0, this will be I, 0 minus 8i. Second, use this part, so this will be 3 root 3 plus I, because b is 1. And if we use the third solution, so this will be minus 3 root 3 plus I. So again we are getting the three same solution as in first method. Let us say its next method. See, the next method is this is the method number 3. This is the method number 3. We have z plus 2i whole cube is equals to 216i. We can write it as z plus 2i whole cube minus 216i is equals to 0. Now I am trying to adjust this expression as either a cube plus b cube format or in form of a cube minus b cube. Why? Because we have the formula, we have the identity in terms of factorization for these two expressions. So let us try to see how, let us try to solve how we can do this. So this minus this 216 can be written as 6 cube, and this I can be written as how? If we write, see, if we write I cube, this will become minus of I, but I want I, so I have to write minus I cube, so this will be minus of minus I, so this will be I. So if I write minus I cube, right, so minus I cube, please see, minus and I cube will give minus I, so again I. So I think here you have understood. For I have written this. I can be written as minus I cube, that should be equals to 0. So this can be written as z plus 2i whole cube minus 6i whole cube is equals to 0. I hope you are getting this point. This is a logical point. So if you have any problem in this step, please let me know in comment section. Okay, let us proceed. So now we have a cube minus b cube, and we have the identity for a cube minus b cube as well. So what's the formula for a cube minus b cube? It's a minus b, it's a minus b, a square plus b square plus ab. So we have to use this, so a minus b, so z plus 2i minus b, and again it has minus, so it will become plus, so plus 6i. So this is a minus b, a square, that is the z plus 2i whole square, a square plus b square. So when we will do the plus b square, so this will become 36 I square, and I square again minus 1, so this will again give us minus 36, right? And a square plus b square plus ab, so plus ab. So let me delete this portion. So plus ab, that is the z plus 2i multiplied with minus of 6i. So let us simplify this. This should be equals to 0. So this will be z plus 8i, and here we have to solve, we have to expand this a plus b whole square, a square plus b square. When we will do b square, it will become minus of 4, so a square plus b square plus 2ab, so plus 4zi minus 36 multiplied by minus 6zi minus 12, and this I square become minus 1, so this will become plus, this should be equals to 0. So let us simplify more. So this will be z plus 8i, this will give us z square minus 2iz, and this will minus 2iz, and this 36 minus 36 minus 4 minus 40 plus 12. What it will be? It will be 28 minus 28. So this will be minus of 28 should be equals to 0. So again we have to use the same concept that the product of two number is equals to 0 when either this will be 0 or this will be 0. So when we equate this z plus 8i is equals to 0, so from here we will get z is equals to minus of 8i, and this is our first answer. Now here we have a quadratic equation in z, that is the z square minus 2zi minus 28 should be equals to 0. So we can apply the quadratic formula here. So what will be the z? Z is equals to, the formula is minus b plus minus under root b square minus 4ac upon 2a. So from this expression a is 1. So what is the b? B is basically minus 2i. So minus of minus 2i, this plus minus under root b square. So b is minus 2i. When we do the square, 4, this minus 2 will be 4, and this I square again minus 1. So this is a minus 4. Minus 4, a is 1, c is minus 28 upon 2a, that is the 2, because the value of a is 1. So let us simplify this. So this will be 2i plus minus under root minus 4 minus minus plus, and this 28 4 ja, this upon 2. So from here we will get 2i plus minus under root 108 upon 4, sorry, upon 2. Now we will factorize this 108 and trying to find its square root. So 2, 5, 4, 2, 27, 3, 9, 3, 3, and 3, 1. So this is paired, this is paired. So this is basically 6 root 3. We can do it directly also, no problem. That is this is the 6 root 3 upon 2. When we will take 2 as a common, I will get I plus minus 3 root 3. So from here we will get 2 root as I plus 3 root 3, or you can say I minus 3 root 3, which is the same result as in previous method. So I hope you have understood all the three methods here. So if you like this solution, please like this video and subscribe this channel for such more questions. Thank you. Thanks for watching.